Please subscribe math.com for any query, comment or email.
Hello everyone. As we have already seen in our previous lecture that how you can solve the algebraic expressions by means of algebraic identities. One of the algebraic identity we will use today, and through examples we will see how we can factorize a given algebraic expression. That algebraic identity is a square minus b square, that is equals to a plus b into a minus b. Okay, so this is an algebraic identity that we will use to find out the factors the factors of an algebraic expression, or to factorize an algebraic expression. So this is the identity that will be used in our examples in order to evaluate the factorization process. Let's apply it on the examples. We have an example that is 4a square minus 25. We will write the identity on one side so that you can easily compare it with that. That was a square minus b square. We will take the left hand side of the identity and we have to find out the right hand side. So let's compare it with the identity. As it is clear that this term is equals to this and this term is equal to this. Okay, so we can say that we can write them in that form. So how we can write them? So we have to write them in square form. Then a can be written as, if we write 4a square. Here a is of square but 4 is not of square. So in order to convert it, we can write as 4 is the square of 2. So we can write 2a whole square. If we remove the square, we will get 4a square. So we can write 4 square as 2a square. Then is 25. 25 is what? 25 is the square of what? We have to keep in our mind the concept of square here. 25 is the square of 5. So we can write 25 as like this. So it is clear that now this expression and this expressions are exactly equal to them. Okay, so we have to use these two expressions in order to evaluate the factorization, the factors of the given algebraic expression. So let's find it out. We have given with the 4a square minus 25, we will replace it with their square form as 2a whole square minus 5 square. Now as we know that this identity was equals to a plus b and a minus b. So we can write this in the we can write our example in the same form as a plus b. Here a is 2a and b is 5. So 2a plus 5. So 2a plus 5 and 2a minus 5. So this is the answer of the given identity by of the given algebraic expression by applying an identity, that is a square minus b square is equals to a plus b into a minus b. So whenever you are given with the questions like this, you have to find the solutions by applying the identity a square minus b square. Let's have one more example. Example is, so this is an example and we have to apply the identity, because I will write it again here as a square minus b square equals to a plus b and a minus b. So let's see how you can apply it on this. So first of all, our step 1 is to convert them into squares. Okay, so before that, as it is clear from here that if we take the common constant out, we can have a factor or one of the factor of this question. So we can write here, we can take the factor 2 here. If we take the take 2 common, then we can easily find its squares. 9a square x square minus 16b square y square. Okay, this we have taken the 2 as common. Now it is clear that we can make these two terms as square easily. Okay, let's convert them into squares. 9 is the square of 3 and a is already square and x is also square. So we will write 3ax and the whole square. Okay, then 16 is the 4 is the 16 is the square of 4 and b and y will be written as it is and this square. So this is how we can convert the terms into their squares. So I can write it as 2 into 3 3ax square minus 4by square. Okay, now we can convert it into the identity's right hand side form, that is this one, a plus b and a minus b. So a plus b will be 3ax plus 4by and a minus b will be 3ax minus 4by. So this is the answer of applying the identity on the given algebraic expression, so that you can easily evaluate its factors. So these are the factors of the given algebraic expressions. Basically our purpose is to find out the factors. One more example is a little bit difficult example. It's a very common example that most of the time we use, x4 minus y4, and we feel it difficult to find its solution. We will use the identity, that is a square minus b square is equals to a plus b into a minus b. So I have to convert it into this form, a square minus b square. So first we will convert in square form is x square into square. If we multiply these two, we will get x4. So this is how we break the power into squares, minus y square into square. So we have got this form. The form is exactly the same as this is. So we can write now in the form of a plus b and a minus b as x square plus y square and x square minus y square. Okay. Now it is clear that this expression is okay, but this expression is now exactly in this form. So we have to further reduce this expression, and we can write in this expression as, first we will write it as it is x square plus y square, and the expression will be x square minus y square, that is a square minus b square. So we can convert this form into this. So we will get x square plus y square into a plus b. Here a is x and b is y. So x plus y, and a minus b is x minus y. So these are the required factors of the given expression by applying the identity a square minus b square. So that's all from this lecture.
Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.